Java 9? Thank you.
Hello everyone. I know Frank already asked this question about how many people are using Java 9. How many of you are actually already on Java 8 in production systems? Awesome. Great. That's a good start for me. Thank you for that. I'm just going to get started. My name is Chandra. I work at Bank of New York Mellon, and I am here to present. Can you hear me better? Thanks. I'm going to present a few features on Java 9. So Java 9 was actually introduced this year, September 21st, and we already have a patch, being a security patch that was released on October 17th. It has been by far the biggest upgrade to Java. It has been 3.5 years in the making. The last release was Java 8, which was released in March of 2014. Java 9 has a lot of features. There is no way we could scope in all those features into a presentation here. We will take up the entire evening, or probably carry over to next day. So I'm going to just try to limit myself to a few of these features. I'll probably spend just a minute on each slide because I have a few slides and I have a short time to go in. We'll reserve the questions for later, and the slides will be made available. So in case you are interested, most of the slides will be just a few 2 or 3 liners followed by a link to where you can find out more information from this. I'm just trying to collate all this information for you at one single presentation. That said, let's get started. I'm going to divide this presentation into a few layers. There's a vertical as well as a horizontal stack here. So the verticals are something that sort of group together features. The first vertical is about language. So what are the language enhancements that were made in Java 9? Let's get started. So the first and foremost that I like the most or find the most controversial is private methods in interfaces. Java has now introduced what is called private methods in their interfaces. Obviously in Java 8 they introduced something called default methods that allow for extensibility. Now we have private methods. So private methods allow you to actually share some common code that you could put either in your default methods or in your static methods. Of course, this leads to a lot of combinations that you could have. 2 combinations are not allowed, which is the private abstract and the private default. They throw compile time errors. There's a small chart over here which tells you what is allowed and not allowed, the colored areas of what is allowed. There's a original bug feature request that we included, and I have a small write-up on my own blog about this. So if you're interested, please do check that out. The next one I'd like to tackle is collections. Collections has new factory methods. How many of you have instantiated collections and done exactly what is written out there? You first create a collection, and then you start seeding it through an add or a put method. Raise of hands, how many people have done this already and hate it? Right? So Java 9 has introduced a new factory method paradigm which allows you to simply declare a list, 1, 2, or a map of key and value pairs. And this has made developer experience much more improved. Obviously there's a GAP associated with it, the link is down there, and there is an Oracle blog about collections refueled that's included. All right. Optionals. This is, how many of you already use optionals in Java 8? It is awesome. I mean, thank goodness there are no more null pointers if you use optionals. I love optionals. And I have a few blogs on optionals already. 3 new features were added to optionals that were missing. There is a 4th and controversial feature that should have been added but not included, which is to deprecate the get method. I did not include that here deliberately because it's still a lot of hot debate going on about that. So the 3 methods added are if present or else. We already had what is called an if present. We had a method called or else. They've just been combined to create a new method signature, if present or else. It checks for a non-null value, else it invokes whatever runnable is passed to it. Or is another awesome feature. Thus far, with optional, we did not have the ability to return an optional all the time. It either returned a value or it did not do anything or threw an error or something of that sort. Or allows you to get away with either getting a non-null value from the existing object or return another kind of optional. Lastly, stream is another API that has been introduced. It allows you to return a sequential stream. This is awesomely useful when you're using collections and pipelines. You can stream your optional, either return a value or return a null, right? And if it's null, it doesn't go forward with the terminal operation. Again, a few links associated with this. Stream itself has few enhancements. Obviously, we had a few sessions on Java 8 collections here already. Some of you have attended those in the past. Stream has new improvements. One of them is called a take while and a drop while. These are methods that allow you to process a stream until you meet a certain condition. In the past, we just had what is called a limit operation, which was just numeric. With take while and drop while, it has been extended to using a predicate, a condition. Also, we have something called an off nullable. An off nullable is essentially what the optional stream does. It's parallel and complementary feature in the stream API is off nullable, which allows you to return a stream based upon the value. Last but not the least is there is now an iterate method. The iterate method on the stream is nostalgic to anybody who's used the for loop, the old for loop with the 3 conditions for the initialization, the condition, and the forwarding mechanism. A stream iterate now has the exact same signature. It helps because you can now be more flexible in how you iterate. Earlier, we would do something like an int iterate to do iterations. With this iterate method, you're allowed to add more conditions that are not just numeric. Again, if you notice, the theme has been take away the numeric and also add other conditions to perform your stream actions. Okay, this one is very, very interesting. I'm sure Craig will be talking a lot about this, so I won't focus too much. But Java 9 has introduced what is called the Reactive Stream API. This is through the concurrency, and it fully complies with the Reactive Streams manifesto. Essentially, the Reactive Streams have the manifesto of process all potentially unbound, any number of unbound elements. They have to be processed in a certain sequence. These are to be asynchronous when they're being communicated across with different components, and they have to have a zero back pressure. Essentially, when you are being bombarded with messages and you have to process them, the easiest way to handle it is take the message, defer it to some other executor or something, and carry on training the queue. You don't want the queue to have more pressure, causing you further delays down the line. That's been introduced. There's something called a flow API in Java 9, and it has interfaces for publisher, subscription, subscriber, and processor. A publisher publishes messages, of course. There is a subscription mechanism the publisher broadcasts. A subscriber subscribes using that subscription mechanism, and the processor is what actually acts upon the message. As of now, there is no network or I/O-based concurrent components, so distributed messaging is still not a go in Java 9. This could change, but this is where we are with Java 9. It's a start. Additionally, because of all this, other enhancements were made possible, which is still a completable future. There is now a timeout, and there is also a subclassing capability that allows you to extend the features of completable features. We included 3 links here. One of them is the actual JEP. There's a Flow API, there's the JDK 9 API from Oracle, and of course there's an Oracle documentation of Reactive Streams itself. So, how many of you honestly have written a Java doc with an add deprecated and enjoyed it? See, no one liked it. The problem with the Java doc version of deprecation was it was just in documentation. No one could do much about it. So also, it required a lot of developer discipline for someone to go in and read that an API was deprecated. Java 5 sort of took that to the next level by adding an annotation called add deprecated on code level rather than in Java doc. Java 9 took it further to make it much more clarified and give it some meaning and purpose. The meaning and purpose you get is there are 2 new parameters that are being introduced. Both of them are optional, of course. And the first parameter is for removal, which is a hint or an indicator that this API will be removed. It is not being replaced, it's being removed. And then since is when it was determined that this API should be deprecated. So the new, this is clarified as I earlier pointed out. There is also a tool now which allows you to scan your API for anything that is deprecated. There's something called a JDEPR scan, deprecation scan, and it actually aggregates over all classes that use any kind of deprecated API. Have a link on a couple of documents about this in the JDE itself. This one is interesting to a few of us. It is very interesting to folk who also develop IDEs, stack traces. a lot of people just see stack traces as, when they run into exceptions. There are people who also like to drop frames and look at other stack traces, and this helps if you actually want to code against it. Earlier, Java had what is called a stack trace element. A stack trace element is essentially a humongous list of every single call stack within that stack trace, and it was always an all or nothing. You always had to get everything and then parse through it. It was painful. With Stackwalker, the new API, slightly different. It benefits from the Java streams and therefore has what is called the filter or skip enablement. It allows you to do what is called a long walk or a short walk. A long walk is nothing but what the stack trace element used to do, and a short walk is where you can constrain or limit to what you want to see. Your stack trace can now be trimmed down to a certain class, a level, a numeric number of call stack elements. They're all possible using the Stackwalker API. Now, obviously, this does benefit where you want to trim down to a known quantity of stack trace calls and figure out whatever you're trying to figure out with it. Be it an exception, be it if you're an IDE developer, you're looking at how to show a call hierarchy, whatever, right? All right, this one is some of you may have already encountered compressed strings way back in Java 6. This was Java's way of string tuning. It allowed your string to be converted into a byte array if you had, let us say, 7-bit ASCII characters and nothing else. And it was off by default. So you had to actually put in a JVM option to use compressed strings, as is indicated by the second bullet point. Now, the author himself has mentioned that this is an experimental feature and was one, and it was limited by design and was error prone. It was introduced in Java 6, deprecated in 7, removed in Java 8. So Java 9 decided to come up with what's called compact strings. Obviously, very much the same philosophy, but the slight difference is, rather than determine when a byte array or a char array should be used, it actually now converts everything into a byte array. Right? Every single string is converted into a byte array. If you just look up, there are actually examples out there, and we will do this in a workshop later. Every string is now represented as a byte array. Any of you who have been programming a while ago know what is called a parity bit. Something very similar exists with compact strings. The first field is called an encoding field, and it is the one that indicates whether the string is being represented as a byte array or not, i.e. it has 7-bit ASCII or more. So the benefit of doing this is that English will not benefit first. Other languages such as Cyrillic, Hindi, Chinese, anything that uses Unicode characters will definitely see a performance benefit from this. This new flag is enabled by default, unlike its predecessor, which was had to be turned on. And there is a way provided by Java to actually turn it off. I don't know why people would like to turn it off, but the feature exists. So feel free, use this feature, turn it off, see the benefits. You will notice that there's a significant difference in how your strings get used in your Java code. Last but not the least on the language side, there this is just a few of the features. I'm reiterating this. I'm actually going to share the link down below, the comprehensive link of all JDK 9 features. It is too huge for me to sum it up in one single slide, but some other salient features are milling the project point. How many of you know what project point is? Right. For those who don't know, project point was Java 7. Java 7 enhancements are now called milling project point, and they have a JPP associated with that. JP itself has a typo, I just indicated that. But it now allows what is called a safe RRs on a private instance method. Final variables as a resource with private resource. This is important. This is something a few people actually have complained about in regular life. When they actually receive, let's say, a string or some sort of a parameter that allows them to use as a string, and they have to redeclare it as a final within their try-catch block. It is painful. It requires you to write additional code. And this, by a mere ability of declaring the parameters as final, you no longer have to redeclare it and use it within your try-catch block. That's a very significant improvement in code quality and developer experience. Last but not the least, what I wanted to point out on the milling project point is the diamond operator. A lot of you in Java 7 might have used where your IDEs automatically convert your diamond operators on the assignment side to actually remove the generic type, right? It's great. You could not do that if you were trying to create an anonymous class. So if you wanted to create an array list of say string, but you wanted to override one of the public methods in the array list, you would have to declare it with the generic type. With Java 7 you don't, and that's a syntactic sugar, but again improves developer experience. Now 197, JT 197, the next feature I'd like to talk about, is not something a lot of people are immediately familiar with, but it does cause a lot of performance improvement. Earlier there was a single code cache that was being managed by the JVM. Now it's more segmented. Segmentation happens with three different philosophies. One is there is a non-method code heap. Essentially, any kind of compile buffers, any kind of interpreters, etc., are what is called non-method code cache. Once you start up your JVM, they don't change. So they go into what is called a long-term cache. Non-profile code is more static code that is not prone to a lot of change or doesn't need further optimizations as time goes by. Those again go into a long-time cache. And last but the last part is the profile code, which is likely optimized to just run as it is now. The next call, it could change, it may require re-optimization, and those are short lifetime caches. There's also process API improvements. This is a huge topic. I cannot put a lot of content about it here. And lastly, I included a link about the JDK9 features, which covers a much more comprehensive set of everything that is being brought up in this version of JDK. Any questions before we move to the next topic? So after the language changes, we have the next set of changes, which I like to call assorted changes, for lack of a better word. These are just important features that don't have a place in the language per se, but are useful. First, my favorite, garbage collection. Java 8 tangled the promise of G1 GC. We loved it. In fact, Java 7 started tangling it. Java 8 brought it up, but then it was removed as a default. We switched back. With Java 9, G1 GC again comes into the fore. It is now the default. Major differences, and we will have a workshop on this as well, is think of the earlier versions of garbage collection as more flattened out with allocation chunks, whereas with Java 9 or with G1 GC, you have what is called a two-dimensional matrix where you allocate different regions. So your memory is actually broken up into 2048 approximately regions of equal size. And each region could be determined as an Eden region, survivor region, or the older tenured region. And the garbage collection actually happens on individual regions. The benefit you get from lower regions is that any region that has more garbage collectible elements in it are tackled first, right? So if there is a young generation, it gets tackled faster, and when everything turns into old is when a bigger garbage collection kicks off. The benefit of this, your stop-to-word garbage collections are actually lower. The pause time is lower, so you actually, most likely, if you have not done something pretty different from what the JVM offers, you will see some performance gains just by using UNGC. Now this comes with some caches, and the gotchas are all listed out there in the Oracle documentation, and we will be doing a workshop on this later as well. Next, how many of you actually understand Java versions, or did not understand Java versions prior to this? It was a nightmare. Just trying to figure out what your version brings to the table. Is this a security patch? Is it better than the last security patch? Is this an enhancement of a build, some patch outside of the security? We did not know. It was not easy. So Java 9 at least, knock on wood, has done the right thing by creating what is called a semantic version scheme for its versioning. There's a major version, which would be 9, and then there's a minor version, which would increment as build patches are improved, and then there's a security patch version. As we just pointed out earlier, Java 9.01 came out. This was October 21st, and subsequent releases will also look the same. However, there is a new proposal to go the Ubuntu style LTS where you have year.month. I'll state my opinion. I don't like it, but so there is a JEP for that. There's the LTS versioning proposal, and obviously I had to include a link to a plea against LTS by Stephen Fulberg, the author of the Java Datetime API. I'm with Stephen on this. Moving on, there's also been compiler enhancements. This is major. This may look like a small thing, but this is actually pretty interesting, is that in a few prior versions of Java, you could actually compile lower. You would set a source and target, and technically get away with assuming that you have a lower version jar available to you. What most people missed out at times was there was also something called the boot class path that you had to set. The boot class path was supposed to point to the rt.jar of that particular version. If you don't do it, you end up using unsupported API for the lower version, which may only have been added in the latest version. A lot of people miss that out. The new -- release tag allows you to actually set the source, target, and release without having to specify all three. Source, target, and boot class path without setting all of them. Java has a standard policy of 1+3 back, and it supports Java 6, 7, 8, and 9. I don't know why anyone would still want to release for 6, but yes, the feature exists. One caveat that you should be aware of when you use -- release is that there are some restrictions that apply to any Java version that uses module support. So when Java 10, I'm not going to say 18.3, when Java 10 comes out, Java 9 might have some issues, right? So that is something that we have to look out for when the next version of Java comes out. JP is associated, and there's a bug associated with why this was created. This is actually pretty important a feature. Very few people utilize it, but it exists and it's important. There are a few other features that I guess the legal compliance and security folk in the room would be more interested in. One of them is called the compiler control. Compiler control used to exist in a prior form as what is called a compile command. These issue directives on how your code is compiled. So you have some code, and you're trying to tweak the code to do something different, and you can issue commands on how you can do that using some directive scripts. I can't get into the scripts right now, but link exists to the documentation. Compiler control is an enhancement of that. If you were to find a bug in the JDK, you have very few choices. You either report the bug, wait for a patch, or you bring down OpenJDK, you fix the patch, try to work it, which is a nightmare in itself. I've seen this happen firsthand. I've not done it, but I've been with the group who's done this. Now, a compiler control can allow you to circumvent some of those bugs and release your own software for your corporate purposes. So that is where it needs a lot of importance. DTLS is another important feature that was added. This is basically a datagram transport layer protocol. What it allows you to do, datagrams are similar to UDP, right? So there's no guarantee that they'll be delivered, but there's always flowing back and forth. TLS over a datagram increases the speed and performance of doing security. There's Oracle documentations for both JSSE and the main page for security that I've linked to. We can talk about this afterwards if you're interested. I love this topic too. Any questions before we move off of enhancements? Now, this is painful. How many of you know about modularity in Java 9 already? How many of you like it? I don't see a lot of hands raised. Sorry, anyone on the other side? Yes, so modularity is painful, but it exists and is for our benefit. There is what is called a project Jigsaw, which was originally again promised in Java 7, moved on and now is available in Java 9. Again, the whole project link is listed out here. I will share the link, obviously, along with the presentation, but let's get into some of the deeper details. So first and foremost, in modularity, what we need to know is that there is something called a Java Platform Module System, JPMS. JPMS is the root of all module structures. I would love to show you that picture, but it does not fit on my monitor. It is a picture of how all Java packages are interconnected. Even if I were to open that, I'm sure none of you will be able to read how many different Java packages exist. What that caused is as time went by, improvements to Java happened, and the RT.jar just kept getting bloated. If you notice, the RT.jar from Java 8 is around 200, 260 MB. And this causes a lot of pain. Not everybody needs everything. How many of you actually have used Java. Let us say SOAP or Java.xml non-null annotations in your regular day-to-day code from Java? You probably use a third-party library, and it probably has an equivalent or an overridden implementation of the same. You did not need that, but it was always there. It was a vestigial organ that you had to carry around. What Java has done now is there is something called a Java-based root module, which is just the core packages, Java Lang, Java Util, core packages that everybody needs to depend on, and that's called a Java base, and then you build on the base. We'll talk about it in the next slide, but just wanted to give you an overview visual, is that now Java does not have what is called an RT.jar. There is no RT.jar, there is no tools.jar. In fact, I'll even go one step further and say, there is no more difference between a JDK and a JRE. You don't need either. So it is just one single Java, right? So all those things about, should I use a JRE, should I use a JDK? The answer is no, you use Java 9, and you get away with all this. We also have some new tools that allow you to link. Some C++ people in the crowd? Awesome. So we know what linkers used to do. They used to create OBJ files. I don't know. So it's been a while. Yeah, so something very similar is now introduced into Java. Java obviously always did what we called in C++ as DLLs, right? So Java was dynamically linked. With the addition of JLink, we've got what is called statically linked libraries, which were the EXCs. I don't want to go into that, I'll probably get beaten up by somebody. The other thing that you would like to know is that there is no more a class path. You don't use class path, you use what is called a module path. It's slightly different. We'll talk about it in the next slide, but just wanted to sort of set that thought. Java itself has been made modular. It is not that they're prescribing something and not doing it. So they're practicing what they preach. Java 9 has been made modular. Therefore, you can create your own JDK. Your JDK is limited to what you want to see. There is, you have the capability to reduce your Java size. You have the capability to improve your performance, improve your security, because if you find something vulnerable and not needed, take it out, right? There is a custom profile called the compact profile that's listed out there. That could be a starting point to look at how you can minimize. There is an associated URI scheme on how to name modules. There are some rules and regulations about modules that you want to be aware of. We will try to cover them during the migration challenges if we don't run out of time. A lot of links about JPMS. JPMS has been hotly debated. There are a lot of naysayers in the EC who actually did not want this, and there are a lot of people who wanted it. In the end, I guess the naysayers won, and we do have a module system with some compromises made. We'll talk about the compromises if time permits. Last on the modularity part, I just want to cover JLink. JLink, as I said, is a linking library. It introduces what's called a link time. This sits between your compile and your runtime. It actually collates and creates your mega structure that you end up converting into an image for the JDK. If you were to modularize your own application as well. This produces a runtime image, and obviously it's not going to be the 262 megs that we were scared of. It's going to be much smaller than that. This descended from what is called JRecreate. It was created in, I guess, late Java 7, introduced in Java 8. This was used to create your micro JDK or JDK for your mobile devices. J2ME was the old name. I think it is now called eJDKs. Included a link about that and the Oracle docs on it. Any questions on modularity before we move to migration challenges? Yes, please.
Are there pre-composed files, like you said, they're customizable?
Correct.
They are.
Are there pre-composed bundles that you could use? There may be a few. So the JDK itself offers 3, but they give you a compact profile that you can start from, and you can start building on top of it. It is not hard to build. What is harder is to understand how the module system works. That is where your pain points will lie. We'll try to cover that in the next section, which is after tooling, of course. Yes, we should talk about modularity.
Will IntelliJ just look at my code and do the right thing and put the modules together for me?
Yes, I would actually say for most part yes. IntelliJ can do a lot of things, and I'm not trying to do any neglects here, but you will still have to spend a little bit of TLC on your own to get it right. Modules sometimes will cover this, but there are times when you use weird things like reflection, and no IDE can help you there, right? So there are some constraints that we'll talk about, but for most part, yes. Good question, thank you. All right, very quickly, I'm not going to spend a lot of time on this. There's just tooling changes. These are awesome, but I'm just going to introduce them. JShell, how many of you attended the Java workshop on JShell? It's a very nice RATL tool that's been introduced in Java. It is about 20 years too late, but it is here. It accepts snippets of code that you can evaluate and execute on a command prompt. There's a in-depth coverage. There's a shell tutorial that you could use. I actually find it very interesting to do small experiments before I actually put it in real code. Now, it is shocking that after 20 to 24 years of Java, we finally have search capability in our Java docs. It's amazing. You can actually go search for any class you want. You don't have to go navigate through the packages and then figure out where your class is on this tiny little right nav, left nav bar. Figure out what your class is and go to it. You just type it. It works. I've seen it. There is a new Doglet API. The Doglet API is an enhancement on how your Java doglets produce. And then it's HTML5 compliant, 100%, which is very nice and awesome. It works very well with new browsers. This is just the Oracle JDK. I had to put up the slide because I personally use Oracle JDK for most part. If you're using some other JDK, I don't know if this applies to you, but the control panel has been improvised. They've removed a few things that are no longer needed. One of the prime being the applet or the plugin support. There's no more of those things, so we're not going to talk about that. And this is the last section. I promise I'm going to keep it short because this causes a lot of headache to a lot of people. Migration challenges. Java 9, if you are simply just using the new cool features of Java 9, the language or the tooling, it's great. The biggest challenges start coming in when you start thinking about modularizing your code. So try to go through some of these. First, I want to point you to the top link, which is risks and assumptions made by OpenJDK, assuming what you're going to go through. And this is the same JDK that we actually linked earlier. There's an excellent resource. This is Nikolai Parlov. I don't know how many of you know him, but his blogs are amazing. You should go read if you haven't read them. He's got what is called a Java 9 migration guide. A lot of these points that I've typed up here have been because of this blog, because that's how I got started when I started with Java 9. The first question I put into Google was, what is going to prevent me from going on to Java 9? And he gave me an answer. So after this, I was sort of apprehensive about going to Java 9 at first. My apprehensions are slowly fading away, but there is still some concern. I'm going to try to share some of those concerns. That dreaded message. Anytime you start coding and you compile and you see that message, illegal reflective access operation encountered, it's painful. You don't know what to do. The first thing you have to understand is if you're trying to access an API that is internal or not available and you're somehow trying to get it. So remember, when you, how many of you actually have heard of no class def found error? Obviously all of you should. Right? Class not found exception. Can anyone tell me the difference between the two? Anyone? Okay. So what is the exact difference? What is the difference between the compile time and the runtime? What is going on? Okay. So I'll give you a hint. A class not found exception is simply telling me that I can't find a class. However, the badly named no class def found error is telling me it could not create a class definition, which means it found more than one definitions of the same class. right? So that's very important to remember. Those exceptions have been replaced with this little text that we see up there, which we don't understand very easily, right? So what you have to do is figure out which APIs you're depending on, whether you need that API or not. I would say try to avoid using that API, but if you can't, there are some workarounds that Java has provided for you. Use the tool called JDEPs. It tracks your dependencies, tells you what you're sort of accessing. But if you're accessing internal or reflection-based API that we were earlier referring to, there is one more flag you need to set. The flag is currently set to permit after a lot of debate online. It was set to warn. It has been moved to set to permit. I would have preferred one. But you should set it to deny to see what you're accessing and what is causing you your problems. So just make sure you go through this list. I'm almost out of time, so I'm just going to quickly wrap up. Java EE modules are now separated. All the heavy load of the RT.jar is removed. So either add the modules you need or use the whole Java SEEE to get access to the entire module structure for JDE. This is something that I would like to cover in detail. I don't believe I have the time to. Split packages are worse than just internal APIs where you have the same package being visible in two different modules. It causes a compile time limit. It will not work. So you have to somehow combine them or figure out how you can avoid relying on one of those. An example is the non-num. We covered that earlier, but there's something you want to be very careful about. My request, don't patch. Try to figure out how to do it right. Obviously, there's a lot of deprecation of the internal API. One of them is reflection. Unsafe. Unsafe is used by a lot of framework developers. If you're using unsafe, we should have a conversation. Put in a link about why these are being deprecated. Obviously, new version strings, a lot of code is written with version strings as checkpoints. If version is this, do something. It has been replaced with a runtime.version. You can still make it compatible using a multi-release jar. You can create a jar in Java 9, which allows you to have core packages and core classes, and you would have under the manifest different versions where the same class would have different files. So you could have an A. class. Under your manifest, you could have version 6, A. class, version 7, A. class, and fix up the right version for your environment. So that's something Java 9 offers. And on that note, we're done. Thank you.